All right, welcome to our next lecture in genetics. Still in genetics. Should be the last lecture, I think, maybe one more. All right, so today we're moving on to sex-linked traits. Sex-linked traits. So if you remember the first 22 pairs of chromosomes, remember we got one chromosome from mom, we get one chromosome from dad. These would be homologous, chromosome pair number 3. Chromosome pair number 15, hey, right here, that's where the gene, one of the genes for eye color is located right there on both of them, of course, because this is homologous chromosomes. You get one from mom, one from dad. But we're not talking about the autosomes, chromosomes number 1 through 22. We're talking about traits whose genes are located specifically on the sex chromosomes, chromosome pair number 23. Here's a male right here. He got an X chromosome from his mom and he got a Y chromosome from his dad. Notice the X chromosome is much larger. So the X chromosome contains a lot more genes, a lot more genetic information than the Y does. And here's a female over here. She has two large X chromosomes. She got one from mom, one from dad. So females have more genes on these chromosomes because they have two large X chromosomes, where males have the small Y. So a lot of times males will only have one allele for these traits, one allele where females will have two. All right, so I said most of this already. So humans have 46 chromosomes. They have 23 pairs, one from mom, one from dad. Remember, the first 22 pairs are called the autosomes because they're the same whether you're male or female. And it's that 23rd pair, the sex chromosomes, which come in two varieties. You have an X chromosome, which is large. Females will have two X chromosomes. She got one from mom, one from dad. And there's also the Y chromosome. So the male over here, they get the big X chromosome from their mom, and from their dad, they get the much smaller Y chromosome. So since this is so much smaller, this one doesn't have as many genes. So the X chromosome has way more genes than the Y chromosome. So in these traits, males are only going to have one allele for these traits on the X chromosome. The Y is too small. So males will have one allele for these traits and females will have two. All right, so now some examples of sex-linked traits. So what are some traits that are on the sex chromosome? Remember, these are traits that are the genes are located on the X chromosome. So females have two X chromosomes, so they'll have two alleles for these traits. Males only have one X chromosome, so we'll only have one allele for these traits. And what are some examples? Color blindness. So here's a little unofficial color blindness test. If you have red green color blindness, you see colors, you just can't tell the difference between. So red and green kind of look the same. So if you're colorblind, you can't see this number right here that's in the middle, and it looks like the number 16 right there. And about 8% of males are colorblind. So I know I have some colorblind students. You may not know it. But less than 1% of females are colorblind. So these traits are much more common in males than they are females because they are recessive traits. So males, if they have one recessive allele, they're going to have these traits. Where females would have to get two of those recessive alleles in order to have these traits, because if they have one dominant normal allele, they won't have these traits. Another one's called hemophilia. That's where your blood doesn't clot properly. So right here, you see a blood vessel. It got torn right here. But then these little things called platelets, they come and they clot it, so you stop bleeding. Where people with hemophilia, if you get cut, it just keeps bleeding. You can't stop. Now you would know if you had this already, so don't be worried about it. Obviously, none of you guys have this. But anyway, so you'd have to go to the hospital and they get it to stop bleeding. And then the third one is Duchenne muscular dystrophy. That's where your muscles kind of waste away. You become super weak. You become where you have to be in a wheelchair. Once again, you don't have this. You would know if you did. So these are three examples of sex-linked traits, much more common in males than females. All right, so why are males more commonly affected with these sex-linked traits? All right, so these traits are caused by recessive alleles. So remember, usually in order to have the recessive trait like blue eyes, you have to have two recessive alleles in order to have that trait. Because if you have one dominant allele, you're not going to have the recessive trait because the dominant allele is stronger. So females, well, first of all, we have the male over here on the left. So he has one X chromosome. So for things like color blindness, if he has one recessive allele, one colorblind allele, little n, boom, he's colorblind because he does not have a second X chromosome. He doesn't have a second allele for these traits. He just has one. Females, on the other hand, over here, she could have one recessive color blindness allele, but since she has two X chromosomes, if her other allele is normal, her vision is going to be totally normal. So this is what's called a carrier. This girl over here, if she's Big N, normal vision, but also carries the recessive allele. She's a carrier because she doesn't have color blindness herself, but she does carry the recessive colorblind allele that she can pass on to her kids. All right, so these alleles are very rare. So it's hard to get one recessive allele, much less two. So these are much more common in males than females because females have their two X chromosomes, so they'll have two alleles for these traits, where males only have one. All right, we talked about this last slide, but let's do it again. Carriers of sex-linked traits. So remember, a carrier is an individual who has one copy of a recessive allele for a disease, but does not have the disease herself. Females are the only ones that can be carriers of these traits because they have two X chromosomes. So here, right here, you can see the genotype for a carrier female. So she's X big H, so she has a normal allele on one of her X chromosomes, and X little h, so she has a recessive hemophilia allele on her other one. She does carry the diseased allele, but since her other X chromosome has a normal allele, she herself does not have the disease, but she can pass it on to her kids. So this is the only way a female can have hemophilia. She has to get two of these very, very rare recessive hemophilia alleles. So hard to get one, much less two. Where males, here's a normal male. He's got one normal allele on his X, nothing on the Y. People are going to want to put an allele on the Y. Don't do it. It's too small. Remember, the X chromosome is too small. Males, for them to have a hemophilia, it's just one. They get one allele. If they have that one hemophilia allele, they will have hemophilia because their Y chromosome has no alleles for these traits. All right, so now two slides of Punnett squares practice, and then we'll call it a day. Some of you guys, yes, we're not done with Punnett squares. Some of you guys rocked the Punnett squares test last time, and some of you did not. Well, we have some more coming. So those of you that did well, good job. We got some more, and they're just as easy. Those of you that didn't, it's not too late. They're really easy. Step one, find the genotype of the parents. All right, cross a carrier female. First, I got to show it's a female. So I give her two X chromosomes. She's a carrier. You can see it right over here. Here's her genotype. So she's got a normal allele, big N, but she does carry the recessive little n. And we're going to cross her with a colorblind male. All right, so first I got to show he's a male. XY means he's a guy. So there's his sex chromosomes, XY. He's colorblind. So he's got a little n, little colorblind allele, Y, nothing. Remember, no allele on the Y. All right, then you just regular Punnett square. I'll put the mom on top. Here's her X chromosomes, big N, little n. So she is not colorblind. She's a carrier, but she herself is not colorblind. And here's the father on the side, X little n, he's colorblind. Y nothing. Y nothing. All right, so here this is gonna be a female. This is their daughters, right? One of their daughters. X big N, X little n. So this is gonna be a carrier female. This is gonna be a rare colorblind female. So first, I'll put her X chromosome. She gets an X little n from dad, X little n from mom. She's colorblind. And then here's the normal male. From mom, this male gets the X big N from up top. From the dad, he gets the Y nothing. And this is a normal male. And this one is going to get the X little n from mom and then the Y from dad. So there you have it. So for these two parents, half their kids will be colorblind, whether they're a male or female, and half their kids will not be colorblind. But all of their daughters, half of them will be colorblind, the other half will be carriers. So in the males, just half are normal, half are colorblind. All right, let's try another one. All right, so here's this one. Remember, step one, find the genotype of the parents. Cross a colorblind female. First, let's show that she's a female. XX. She's colorblind, so somehow she got two recessive colorblind alleles. Very difficult to do. And then we got a normal male. So the husband over here, he's got the X that he got from mom, normal allele. And then on his Y chromosome he got from dad, there's nothing. All right, I'll put the mom on top again. She's colorblind. So first I give her two X chromosomes. She has two recessive little n alleles like that. I'll put dad on the side. Here's his X chromosome he got from mom. Normal allele. And then Y, nothing. Nothing. You're going to want to put them here. I know you'll forget. Don't forget. Nothing on the Y. It's too small. All right, now let's just fill it in. So this daughter here is going to get an X big N from dad, X little n from mom. She's a carrier female. So let's go ahead and scratch this one out. Since these are both X little n, let's go ahead and scratch this one out. We don't need to do it twice. All right, so half their kids are going to be carrier females. All of their sons, because look, going to get the X little n from mom, Y nothing from dad. So 100% of their daughters are going to be carriers. They're not going to be colorblind, but they'll be carriers. But 100% of their sons will be colorblind. All right, so there's two. We're going to do two more. All right, so two more. Now this is with hemophilia, not color blindness, but don't. It's this exact same thing. The only difference we're using an H instead of an N. So they work the same. All right, so this one we're going to cross a normal male. Step one: find the genotype of the parents. So first, show me he's a male. Give me the X, Y. Now I know it's a guy. X, Y. So he's normal. So he's got a normal allele on his X chromosome. Nothing on the Y. And we're going to cross that with a carrier female. So first let's show she's a female. XX. She's a carrier, so she has one dominant allele and she carries one recessive hemophilia allele. All right, once again, I'll put the dad on side. So to his daughters, he's going to give the X big N. To his sons, he's going to give the Y nothing. Now put mom on top. To half of her kids, she's going to give the X big N, normal allele. And to the other half of her kids, she's going to give the X little n hemophilia allele. All right, so here's this daughter. She's going to be totally normal. Normal allele from dad and gets the normal allele from mom. This daughter over here, she's going to be a carrier. She's going to get a normal allele from her dad, and she's going to get the hemophilia disease allele from her mom. But she herself does not have hemophilia. Now here come the sons. This one is going to get the X big N from mom, Y nothing from dad, totally normal male. And now this son right here, unfortunately for him, he's going to get the X little n from mom, Y nothing from dad, and this son will be a hemophiliac. So for these guys, 100% of their daughters will not have hemophilia, but half of their daughters will be carriers. Half of their sons will be totally normal, and the other half will have hemophilia. All right, we're going to try one more. All right, last one. Once again, step number one, find the genotype of the parents. You should know genotype by now. That's your combination of alleles. Phenotype is your physical trait. So whether you have hemophilia or not, that would be your phenotype. Your combination of alleles is your genotype. All right, so cross a hemophiliac male. Once again, let's show that he's a male. Give him his XY. All right, he has hemophilia, so he has a recessive little n on the X. He's got nothing on the Y. And then the mom, she's a carrier. All right, so first let's show she's a female by giving her two X chromosomes. She's a carrier, so she has one normal allele and one diseased recessive allele. All right, once again, we'll put mom on top. So she has two X chromosomes. Put them there. One of hers has the normal allele. The other one has the diseased hemophilia allele. The dad is a hemophiliac, so he's got the X little n that he got from his mom, and then he got the Y that he got from his dad. I just fill it in. Can't cross any of these out because these are obviously different X and Y, and these are different X big N, X little n. All right, so this right here, this is going to be a carrier female because from mom, she's going to get the normal allele up top. From dad, she's going to get the hemophilia recessive allele. This is going to be a hemophiliac daughter, very rare. So she's going to get the X little n from dad, of course, because that's all he's got for the daughters. And unfortunately for her, she got the diseased allele from mom, so she does have hemophilia. To the sons, this son from mom gets the normal allele, X chromosome with a normal allele. And of course, from dad, he's going to get the Y nothing. And unfortunately for this son, from mom, this time he gets the X little n allele. And from dad, he gets the Y nothing. All right, so in this case, half of their daughters are going to be carriers of hemophilia. Half their daughters will have hemophilia. Half their sons will be totally normal. Half their sons will have hemophilia disease. All right, so this is how you do it. It's very simple. Quiz time coming up, so hopefully you took some notes, and I'll talk to you next time.